Okay, my first thing to do is just see if I can get the antiderivative over here. And I'm looking at it, and it certainly looks like an integration by parts. Now, granted, if you know the antiderivative, if you write it down, you don't go through what I'm doing over here. But I'm going to write down, u equals ln x. And then I can write down dv equals x dx. du equals 1 over x dx. And v would equal x squared over 2. All right, I'm not worried about the integration of constant until I remove all the integral symbols. So what do we get over here? We get, x ln x dx. Let's see, uv. So I'm going to get x squared ln x over 2 minus, and let's see, we're going to get, let's see, x squared over 2 times 1 over x dx, x squared ln x over 2. And it's going to give me, let's say, it reduces, you get an x there, and the 2 comes out, so you're going to get the antiderivative of that's going to be x squared over 4. Let me just check that again. The x cancels, I get an x. The antiderivative of x is going to be x squared over 2. And I already have a 2 there, so it's a 4. Looks pretty good. Then plus constant. All right? So I know my antiderivative. All right, now someone says, if you know that, what are you going to do about that? They didn't ask for the antiderivative. They asked for an evaluation. All right, so let's write this over here. And I'll write this down now. So what do I know about this over here? I'm looking at it, and there is a problem at 0, by the way. So I can write this over here. Limit as a goes towards, let's see, 0 from the right side. Let's put the antiderivative down, without the constant, of course. What do you get? X squared ln x over 2 minus x squared over 4. And this limits of integration, this one's going to be from, let's see, a to 1. Well, I think I can write this down. And if I do 1, what are you going to get? The natural log of 1 is 0, so that's pretty good. So you can get, let's see, minus 1/4. That's easy. And then I got the limit problem to worry about. It's going to be minus the limit as a goes to 0 from the right side. And I got to be careful over here. And it's going to be a squared ln a over 2 minus a squared over 4. And then the question is, I wonder what that is. All right, let me get my eraser out, and I'm pretty much done. Again, so multiplicity, I'm kind of wondering, can I do that limit now? All right, I'm going to get rid of my antiderivative too. All right, just want to go through it briefly with you, talk about what's happening over here, and let's take a look at that. And I'm going to do it. All right, I know, for example, I know this thing goes to 0. My question is, I wonder what this thing's doing over here. I'm going to write a little differently. I'm kind of curious about the limit now. So it's limit. I'm going to write it with a more familiar letter, by the way. X goes to 0 from the right. And then I'm going to write, I'll pull the 2 out. And then I get the natural log of x. And that's going to be 1 over x squared, or x to the minus 2. All right? So I'm looking at this thing, and the top goes towards minus infinity. And the bottom goes towards infinity. All right? So I got L'Hopital's rule. I'll put this down for you. And what do you get there? Let's write this down. You get 1/2. I'm using L'Hopital's rule. Limit. X goes to 0 from the right. And then what do you get there? You get 1 over x on top. That's its derivative. The bottom's going to be minus 2 over x cubed. Now it looks complicated to look at, doesn't it? So let's write this a little differently. 1/2. The limit. X goes to 0 from the right. I do see a minus. I'll pull it out on the outside. And what do you get there? Well, I'm going to multiply top and bottom by x cubed. So you get x squared. And on bottom, you're going to get the 2. I've already pulled the minus sign out. What's that limit? 0. So what do I got? I know this limit. This limit over here, this goes to 0, and this goes to 0. So what do I now know? I know this is -1/4. So what's the question over here? Evaluate. We just evaluated, and we found that it's equal to -1/4. Thank you.